The Panama Canal, a marvel of modern engineering and a crucial artery for global commerce. A ribbon of water carved through a continent, it stands as a testament to human ingenuity and determination. The canal is not just a waterway, it is a symbol of what humanity can achieve when faced with seemingly insurmountable challenges. This engineering marvel connects the Atlantic and Pacific Oceans, creating a vital link that has transformed global trade. Its impact on global trade is immeasurable, facilitating the movement of goods and resources across the world. Before the canal, ships faced a daunting journey, navigating treacherous waters and unpredictable weather. They had to sail around the tip of South America, a route fraught with danger and difficulty. This added thousands of miles to their trips, increasing both time and cost. The Panama Canal changed everything, offering a safer, faster, and more efficient route for maritime trade. It shortened travel times and revolutionized shipping routes, making global trade more accessible and efficient. The canal is a vital artery of world trade, a lifeline that supports the global economy. Over 14,000 ships transit the canal each year, carrying goods to and from every corner of the globe. They carry millions of tons of cargo, from raw materials to finished products, from cars to clothes, electronics to food. The canal facilitates the flow of goods worldwide, supporting industries and economies. The history of the canal is fascinating, filled with stories of ambition, struggle, and triumph. The French first attempted to build it in the late 19th century, driven by a vision of connecting two oceans. But they faced immense challenges, from the harsh tropical environment to the technical difficulties of the project. Disease and landslides hampered their progress, causing significant setbacks and loss of life. The United States took over the project in 1904, bringing new resources, technology, and determination. They completed the canal in 1914, marking the beginning of a new era in global trade and transportation. The Panama Canal is a marvel of engineering, a testament to human ingenuity and determination. It spans 50 miles across the Isthmus of Panama, connecting the Atlantic and Pacific Oceans. The canal utilizes a sophisticated system of locks, which are crucial to its operation. These locks raise and lower ships to different elevations, allowing them to navigate through the canal's varied terrain. This is because the Panama Canal is not at sea level, and the terrain it traverses is quite challenging. It traverses a mountainous terrain, which required innovative solutions to overcome. The locks are ingenious structures, designed with precision and care. They are essentially watertight chambers that can be filled or emptied to move ships up or down. Gates at each end control the flow of water, ensuring the process is smooth and efficient. To raise a ship, the lock gates behind it close, sealing the chamber. Water then flows in, lifting the vessel to the desired level, a process that is both simple and complex. The process is reversed to lower ships, allowing them to descend to the next section of the canal. The canal also features artificial lakes, which play a crucial role in its operation. Gatun Lake is one of the largest artificial lakes in the world, created to provide a navigable waterway. These lakes were created by damming rivers, a monumental task that required careful planning and execution. They provide a navigable waterway for ships traversing the canal, making the journey smoother and more efficient. The Culebra Cut is another impressive feat of engineering, a 9-mile channel carved through the Continental Divide. This 9-mile channel was carved through the Continental Divide, a task that required immense effort and resources. It required excavating millions of cubic yards of earth and rock, a testament to the determination and skill of the engineers and workers involved. A ship's journey through the Panama Canal begins at either the Gatun Locks on the Atlantic side, where the vast expanse of the ocean meets the intricate engineering marvel of the canal. The Gatun Locks are a series of 3 lock chambers that lift ships up to the level of Gatun Lake, a man-made lake that forms a crucial part of the canal's waterway. Alternatively, the journey can start at the Miraflores Locks on the Pacific side. These locks are equally impressive, consisting of 2 chambers that raise ships to the level of Miraflores Lake before they continue their transit. Approaching these massive structures, a container ship dwarfs most other vessels, including the small boats that often navigate nearby waters. The sheer size of these ships is a testament to the scale of global trade, yet even these colossal ships seem dwarfed by the scale of the canal itself. The Panama Canal is a monumental feat of engineering, stretching over 50 miles from coast to coast. Before entering the first lock chamber, A ship is boarded by Panama Canal pilots. These pilots are experts in navigating the canal's unique challenges and are essential for ensuring a safe passage. These highly skilled professionals take temporary command of the vessel, working closely with the ship's crew to maneuver through the narrow and complex waterway. They are responsible for safely navigating the vessel through the canal, using their extensive knowledge and experience to guide the ship through each lock and channel. The ship is also connected to electric locomotives, often called mules. These mules play a critical role in the transit process. These powerful machines run on tracks alongside the lock walls, providing the necessary force to keep the ship steady and centered. They guide the ship and keep it centered within the chamber, preventing any lateral movement that could lead to collisions. This prevents collisions with the lock walls, ensuring the ship's hull remains undamaged throughout the transit. As the ship enters the first lock, the gates close behind it, sealing the chamber and allowing the water level to be adjusted. The water level begins to rise, lifting the ship gradually and smoothly. This process is carefully controlled to ensure the ship's stability. This is the start of the ship's ascent to Gatun Lake, the highest point of the canal. From here, the ship will continue its journey through the remaining locks and channels, eventually reaching the opposite ocean, completing its transit through one of the world's most important waterways. The Panama Canal's lock system is a marvel of hydraulic engineering. Gravity and a network of culverts and valves control the flow of water. It's a delicate dance of immense forces. Each lock chamber is filled or emptied through a system of culverts. These are large pipes located beneath the lock chambers. Gravity pulls water from Gatun Lake, or on the Pacific side, the higher chambers, down through the culverts to fill the chamber below. Massive valves regulate the flow of water through the culverts. These valves are carefully controlled by operators. They ensure a smooth and even rise or fall of the water level within the chamber. It takes approximately 8 minutes to raise or lower a ship 85 feet, the height difference between each lock chamber. The entire process is incredibly efficient and precise. Section 5. Ascending to Gatun Lake. As the ship ascends through the 3-step Gatun locks, the surrounding landscape transforms. What was once a bustling port gradually gives way to lush greenery. From the deck of the ship, passengers witness a unique perspective of the Panama Canal. They see the intricate workings of the locks up close. The towering lock walls and the powerful locomotives create a sense of awe and wonder. Gatun Lake, once a vast rainforest, was formed by damming the Chagres River. It covers an area of over 160 square miles. This man-made lake serves as a navigable waterway for over half of the Panama Canal's length. Section 6. Navigating the Continental Divide. After traversing Gatun Lake, ships enter the Culebra Cut. This narrow channel cuts through the Continental Divide, the highest point on the isthmus. The Culebra Cut is a testament to human perseverance. Excavating this channel was one of the most challenging aspects of the canal's construction. Landslides posed constant threats. Today, the Culebra Cut is a scenic highlight of the Panama Canal transit. The steep rocky walls, often adorned with lush vegetation, create a sense of awe. Ships navigate this narrow passage with precision, guided by canal pilots and sophisticated navigation equipment. The passage requires careful maneuvering, as the channel is only 500 feet wide at its narrowest point. Section 7. The Descent to the Pacific. After navigating the Culebra Cut, ships approach the Pedro Miguel locks. Here, they descend one level, dropping 31 feet to Miraflores Lake. The Pedro Miguel locks mark the transition from the freshwater of Gatun Lake to the tidal waters of the Pacific Ocean. The change in water levels requires careful management to ensure a smooth transit. From Miraflores Lake, ships enter the 2-step Miraflores locks. These locks lower the ships the remaining 54 feet to sea level, where they exit the canal and enter the Pacific Ocean. Section 8, a modern marvel, expands. In 2016, the Panama Canal underwent a major expansion. This expansion, known as the Panama Canal Expansion Project, added a 3rd set of locks. These new locks accommodate larger ships known as New Panamax vessels. The expansion has significantly increased the canal's capacity. It has also led to the use of larger container ships, which can carry more cargo. This has had a major impact on global trade. The new locks are marvels of modern engineering. They use a water-saving basin system. This system recycles a significant portion of the water used during each lock operation. This makes the canal more environmentally friendly. Section 9. The future of the Panama Canal. The Panama Canal faces challenges. Climate change threatens the canal's water supply. Increased competition from other shipping routes is another concern. However, the Panama Canal Authority is committed to ensuring the canal's long-term viability. They are exploring ways to address water management issues. They are also investing in technology to improve efficiency and safety. The Panama Canal remains a vital artery of global trade. This engineering marvel continues to connect the world and facilitate the flow of goods. As we look to the future, the canal stands as a symbol of human ingenuity and international cooperation.